My class project is about face anti-spoofing. Let's talk about it. With the rapid development of computer technology and the continuous progress of computer vision, biometric identification technologies such as face, iris, fingerprint, palm print, DNA structure are widely used in security systems and authentication systems and other fields. They gradually replacing traditional methods such as handwriting, seals, signatures, and keys. With the continuous updating of technology, the recognition rate of biometrics is also steadily improving. Among all kinds of biometric identification technologies, face recognition is widely used in criminal investigation, monitoring system, online authentication because of its high security, good stability, naturalness, and concealment. And many attendance systems and safety detection technologies uses this technology, such as swipe face to pay or swipe face to unlock something. And this figure illustrates some applications scenario of the face security authentication system. Let's take a look at several algorithms now. The first is face anti-spoofing using pattern depth-based CNNs. First, this article shows that using the face depth map at the difference between the living body and the non-living body. Because the face in the screen is generally flat and the face in the paper is distorted, and the 3D distribution of the real face is also different. One of the two signals is identified from a local perspective, which can obtain some spatially irrelevant features, and the other is identified from a global perspective, which identifies the global imaging depth as a distinguishable feature. Although this method is relatively new at that time, its performance did not surpass that of traditional method. Second is learning deep models for face anti-spoofing binary or auxiliary supervision. And the article published in CVPR 2018 finally surpassed the performance of traditional methods. The convolutional neural network part is used to evaluate the depth map and the feature map of each frame. And the recursive neural network part is used to evaluate the time dimensions of the feature map of the entire sequence. The third is discriminative representation combinations for accurate face spoofing detection. It shows that SSD plus SPMT method first uses SSD for judgment. If the judgment of face is uncertain, SPMT is used to characterize local features, and this can ensure that features have multi-scale characteristics. The method of TFBD plus SPMT requires the use of binocular images, takes binocular depth as a feature, combines SPMT and TFBD, and finally performs fractional level fusion. And the fourth is this spoofing. In this paper, the living face graph is regarded as the original graph, while the non-living faces graph is regarded as with added noise distortion. So the task becomes the estimation spoof noise and then uses this noise pattern feature to classify the decisions. The single frame method was done by the same research group of MSU. The idea of this paper is very interesting, inspired by imaging denoise and imaging blur. Both noise graph and fuzzy graph can be regarded as adding noise of operation or fuzzy operation on the original graph, while denoising and jitter removal are estimation of noise distribution and fuzzy kernel. Thus, restructure the original graph. In this paper, the living phase graph is regarded as the original graph. And next, I will introduce my algorithm. In the original implementation, all features are first interpolated to the size of each W equal to 3232 after contact, and then sent to a convolution plot and a review layer prediction depth, whose size is CHW equal to 13232. The true value of depth is given by the label spoofing or not. If it's real imaging, then depth GT is a tensor that has the values of CHW equal to 13232 for all 1S. Otherwise, depth GT feels 0. When calculating loss, the original implementation calculates element-wise MSE loss and contrasts depth loss of depth print and the depth GT. In the prediction, the mean value of depth spread is directly used as the probability that the emergence is alive. On the test set generated by the dataset sampling generation method described in section 1, the classification accuracy of the model is 94%, which can be obtained by running test OULU.py. OULU dataset has good illumination conditions and high imaging resolution. We use the computer front camera for testing, and its differentiation degree is worse than that of OULU verification set, as shown in the figure below. As for conclusion, the model of biometric identification, face recognition, and the liveness detection have been widely used after decades of development, and commercial companies based on them have emerged in an endless stream. This report reviews the development history of face recognition in the past and introduce various achievements of face recognition. In particular, the rise of neural network in recent years has brought the accuracy of face recognition to new heights. However, there are still many problems and challenges to be solved in the future research of face recognition and the living body detection based on neural networks, which are respectively reflected in the three pillars of deep learning: big data, big models, and big computing. And finally, I will show you a video that shows the effect of the program.